C'est du Saturday. Yes, okay. I received a request that they want us to do this and this. Okay, before I do it, guys, feel free. Mr. Bubakar, you called me earlier. I don't really remember. You were talking about chapter 19. Point what?
19.2. But I'm trying it now, so I will let you know.
19.2 is the one that we did last time, right?
Yeah.
Did I record it? Guys, please remind me after today's class to send all the recordings that I've recorded. I don't know if why I forget, but tonight remind me. I'll go on YouTube, update, and then share the links. Okay, this is what we're gonna be doing tonight. This is it. It is on page what again, Mr. Kotso? That question. I think it's chapter 16. Chapter 16. My books. I have joy whenever I give class. My heart is full of joy. Calculate the principal stress, maximum shear stress, and the orientation at point A, B, and C. And then they said the outside and inside diameter. Oh, pipe 150 and then 110 respectively. Here we have outside and inside diameter. Interesting. Really interesting. Okay, what's the question? We have outside and inside diameter. So for the inside, we're gonna call it small d, which is 110 millimeter. For the outside, we're gonna call it big D. Mr. Bubakar, you did this question, right?
Yeah, I tried. I tried.
You got it.
Yeah, some part I'm confident, some other I'm not that confident.
You didn't want to share with me. Okay, guys. Yeah, we know the story. When we have something like this, we study the effect of each force and what it is doing under this system. Now, we have two forces in our system. We have, okay, basically we have something like this. We all can see it. You have one force pushing it down, 12. You have one force pulling it this direction. I don't know if it's the right way of drawing it, but it's basically something like this. So yes, I'm coming. Allô, Yves?
Bon, Samuel.
Allô, Yves?
Allô?
Allô, oui, je
Bon,
t'écoute.
je cause avec papa.
Hmm.
Comme c'est 500 000.
Yeah.
Papa a dit, comme toi tu as dit, fin septembre, tu devais donner 5 000 reins.
Yeah.
C'est ça, non?
Oui.
Donc, convert 5 000 reins, donc nous, 5 000 reins, ça fait. Donc, il va manquer 10 000 reins, c'est ça, non?
Oui.
Donc, nous, on va compléter, nous, on va faire 10 000 reins d'ici là.
Mais non, mais ça
Donc,
sera.
5 000 reins, ça fait 277 dollars comme ça là. Donc, toi, tu as dit 840 dollars, moins 277 dollars. Bon, on va apporter le reste là. On fait septembre. Comme ça, dès qu'on envoie ça, tu payes tout et tu prends le diplôme une bonne fois.
Ok.
Après, tu fais la translation, tu envoies pour commencer la procédure dans le mois.
Maintenant, mais j'allais dire, quand on va commencer aussi le visa, ça sera pas beaucoup pour papa.
Je crois que ça prend 2 semaines, non?
Ah.
L'agent du visa, il a dit c'est bon, ça c'est bon déjà. Tu fais ce mois-ci. Maintenant, ça, on va faire ça à la fin du mois.
Ok, y'a pas de problème.
Pour éviter le retard.
Oui, oui.
Donc, il faut seulement faire vite là-bas, organiser ça.
Ok, y'a pas de problème.
Pas seulement d'être faire vite, de faire vite. Bon, ça va. C'est un peu ça. C'est tout, on fait comme ça.
Ok.
Sharp. Coupe seulement.
Okay.
C'est bon.
Okay, sorry guys, I was on the call. What were you talking about? Sorry for the cut. Okay, this is what's happening. We have a force of 10 kilowatt pushing this way. Now we have to know what is the effect of each force under this element here. Remember what I said, whenever we have something like this, we always draw axes. You come around your point of connection here. You can draw this. Usually we call this axis to be y. This axis here to be x, and this axis going up here to be z. Now why is this important? It gives us direction of our moment and where it is rotating about. Now the force 10 kilonewton here, it can also be represented as a force coming straight here to this point. It's 10 kilonewton. Because of that, the effect on point A, B, C, this 12 kilonewton here, is causing what we call a direct force, which is a compressive force under this moment, because it is acting straight where our point of connections are, where our point of study are, A, B, C. Now for this case, what do we do? Let's start with 12 kilonewton. What does it cause under this system? We have 12 kilonewton. Oh, I have so many calls. Sorry guys, just family call. Hello? Oui, allô, Dora?
Allô?
Oui, allô?
Oui, mais ok.
Ah, Dora.
C'était une erreur. J'allais appeler Chabrel pour lui dire ce qu'on a causé avec papa. Donc on va prendre le diplôme à la fin du mois. À la fin de septembre. Son diplôme. Comme ça. Fin septembre, c'est bon, non? Comme ça, vous allez traduire après. Au cours d'octobre, vous allez faire la procédure.
Oui, c'est ça.
Ok.
C'est bon.
Ok.
Sharp.
Sorry guys, I'm really sorry for that. Now I'm back. 12 kilonewton. What is the effect of 12 kilonewton under this element? It creates a compressive force. Now we know because of a compressive force, it creates a stress of F over A. What is F in this case? F is 12, the force 12 kilonewton. So you can put it 12,000 divided by the area. But now what is the area? This element here has inside and outside diameter. Under this case, the area is pi over 4. You open d big square minus small d square. So now what do we have under this case? Mr. Bubakar, is this what you did when you were solving?
Let me check.
Big diameter, you put it in liter, 0.11. No, the big diameter is 0.150.
Yeah.
0.150 square minus, okay my brother, thank you Mr. Bubakar. Now if you do this, what do you get? You get a compressive direction because it is going where the point of study are. If this force was going opposite direction here, this force would be a tensile force. That's the difference. So now, what is the answer? Guys,
It's ice 1.47 MPa.
Did they got any answer here like that here? Under the answer 1.4?
I don't know. 1.47 MPa.
1.47 MPa. Okay, we'll find it as we solve. Now, here we go. It is a compressive, it has to be negative. Negative, or you can write the force and then you put a C like this for compressive. Now, you look at the 12 kilonewton now. What is the other effect that is causing under this 10? What is the other distance that what is the other effect that is causing under this system? To know that is quite easy. You just look at under this system here, the force 12 kilonewton. What is it perpendicular to? What is, remember, force times distance create a moment. What is the perpendicular distance of the force 12 kilonewton? We all can agree that it is 1, right?
Yeah, 1.
1. It cannot be this one because 1 and 2 they are on the same line. You cannot get a moment of where you are on the same axis. It's impossible. Now it is 1 meter. What's happening? 12. You can see direction of 12. It is acting on the Z direction. Direction of 1 meter. It is acting on the Y direction. So it means this object will be bent like this around the x-axis. I don't know if you guys see it. It will create a bending moment. This will not create a shear. Why? Because this force is creating a compressive force first before the bending. Due to that, it cannot create a shear under this system. Now, due to that, what is the formula? When we have a bending moment, which one do we have? We have a direct stress also created of what? Of my over I. Now we are simply doing calculation and we're going to see the effect at each point of my over I. So what is m? Moment. It is 12,000 times 1. What is y? Okay, this is a good one. Y is the radius of the circle. But we do have 2 diameters, big and small. Under such cases, you consider the radius of the biggest diameter. What is what? 0.15? Can you please mute yourself, Mr. Baka? Which is
It is not me.
which is the diameter here is 150. If you divide by 2, it is 75. So the radius here would be 0.75. Yeah? The 0.75 or 0.075?
You can't see your screen, Mr. Ice.
0.075.
You can see my
You
screen,
can't see your screen.
but I'm sharing.
And now
Yes.
we can.
Oh, now you can. Here, can you? It is 0.075. Guys, let's do this quick. Please. Over I, it is pi over 64. Now, this is a good thing. For
Yeah, Ice, is it 1 or 0.01 here?
where here?
Next door.
Here.
Yes.
It is 12,000 times 1 meter. 12,000
Isn't it?
times
Oh,
1
1. Oh, yeah. I see.
times y here 0.05. Now, when we calculate the I here, remember I for this, the formula is pi over 64 d to the power 4. Because we do have outside and inside diameter, the formula will change to bigger diameter 0.1. Now we are talking about 0.15. Let me erase this side to write it properly. 0.15 to the power 4 minus 0.11 everything to the power 4. You get this, you have that's bending moment stress due to 12 kilonewton. What is the answer? Guys, please, let's be quick.
I am getting 50.95 MPa.
50.95 MPa. Now we are done with the first 12. Let's do the study now with the first 10 kilonewton. Now 10 kilonewton, what is it causing on our system? For you to know it is quite simple. Now what do? You look at the perpendicular distance that 10 kilonewton is having. 10, as you can see, 10 here is creating a perpendicular distance here, which is 2 meter. 2 meter, and this is the 10. Due to that, we have a moment. Now it is also having this with the distance down, where you have 10 and this side is 2 meter. Remember, this distance here is 2 meter. It is also creating a moment. Now it is important to know, to see now which one will create a shear stress and which one will create a bending moment. Easy as that. Do you agree that when I take that, let's look at this, 10 here simply mean it is going on the x direction? Do we agree? 2 meter here simply mean it is moving on what? Y direction. So definitely this thing will be turning around the z axis here. But what's happening when it is turning around the z axis? It will be turning like this. I don't know if I can represent it in 2D, but you have to be able to picture it. It will be having something like this, like turning around itself. So due to that movement, why is this turning around itself? The other reason is it is rotating at the axis where our point of study are. It will create what we call a shear stress. Now there is two things that come up here under the 10 Newton. There's a shear stress created by this force, and there is a torque. Why is the torque created? Because this object is rotating around the point of study. So for 10 kilonewton under this case here, we have a shear stress due to the force, and this is how we write that formula. We said shear stress is equal to VQ over IB. Now what is V? V is the force. It's simply V is the force applied. V is the force applied, which is 10,000 under this case. Multiply. What is Q? Remember, we study a centroid. Basically what's happening is, remember always this scenario that I always show you. If you can look at it in 2D, this is how it is. You have A, you have B, and you have C. This force 10 kilonewton here, it is actually acting like this. Do you see? It is acting where B is. It is acting like this 10 kilonewton. Due to that, point B is the neutral axis. The shear force will only gonna be felt around the A axis and then C axis, because this point they are not on the neutral axis, and I've explained it I think earlier in one of our first classes. We spent some good time on this. Now, and when we do this study here, we are studying half a circle, half a section of where the shear is happening. That is the reason why we use the centroid of half a circle, a semicircle. If you remember in mechanics 1, we had something like this. When you find the centroid, we guys were calling it y bar. It was 4r over 3 pi. So now Q is equal to a y bar. That is the formula of Q. In other way, you don't need to write it like this. You can even just write the direct answer. We proven it last time here. This simply means the area, since it is a circle, it is pi r square over 2. Y bar is 4r over 3 pi. So what usually happen here, pi cancel pi, 2 cancel with this, so at the end of the day you have 2 over 3 r cube. This is what you need to remember. So whenever you have something like this, you can simply come and write 2 over 3 and r cube, which r is this one. You always work with the biggest radius when you have 2 diameters. So under this case, the radius here is 0,075. Remember, the biggest diameter is 150, so the radius is this divided by 2. Therefore, to the power 3 divided by I we go again, pi over 64, diameter. Now we use same formula as this one, that I there. Yeah, good. What is B? Remember, B, I told you, is the thickness, the diameter. Remember, when we are doing this study, we are dealing with the big diameter. We only include the small one when it comes to calculate the area and the moment of inertia. That is where they are being included. Otherwise, the thickness here will be the big diameter, which is 150. So under this case, it's 0,15. So what is the answer? This is the shear stress created by force 10. What is the answer?
I think the answer should be 1.061. That's what I got, but I can still.
1.061.
61. Yeah.
Like this.
Yeah.
Megapascal.
Yeah.
Okay, Mr. Bubakar, thank you. Now, guys, the same force 10 is also creating a torque. Why is the torque created? Because this object is rotating around our point of study, around the axis where our point of study are.
Or you can make it 6-2, because it's like after that one there is 5.
But I'll leave it like that. It's just gonna 6-2. Okay, Mr. Bubakar. How do we do? Now, the same 10 kilonewton is creating a torque. So there is a shear stress due to the torque. So that shear stress, it is written like this. This is a right chain mistake. For the shear stress, this is the right chain. This is the torque. It is TRJ. T stands for the torque. Remember, torque is force times perpendicular distance. So now let's see what's happening. The force is 10, the perpendicular distance in this case is 2. So you have 10,000 times 2. The radius, this big R, the radius is 0,075. And what else do we have? What do we do? We have J. What is J? J is pi over 32. So now we're gonna be having big diameter of minus small diameter like we've been doing. Guys, are you with me? I hope we following what we are doing, right? Mr. Koso, are you with me, my brother? What's the answer?
Yes, yes, I'm following.
Copy the answer, my good people. I'm sorry, I gotta be fast today.
Mr. S, I'm getting 42.42 MPa.
42.42 MPa. Like this. This is it, right?
42.46, Mr.
46.
42.46.
Okay, what else, my good people? Now, this is what the effect that we have of 10. Is it the only effect? No. Let me erase. I think it's a mess around this area here. Let me erase to see what is happening. Now 10 is creating a shear along the YZ axis. Now what's happening again? 10 will also cause a bending along the y-axis. The y-axis, how will I know? 10 is on the x-axis. The perpendicular is on the z-axis. Therefore, this thing will be bending around this y-axis. Do you guys see it? You can just see where something will bend or rotate about just by using this method. You know that 10 is going this direction. You know that the perpendicular sine 2 is z direction. What is left? You already use x and z. Only y is left. Due to that, you definitely know that this thing will have to bend around the y-axis. So we all know that we have what we call a stress due to the bending moment. So that stress here would be my. Now what do? The force is 10,000. The perpendicular distance is 2 as well. The perpendicular distance is 2 times y here. Remember what we do, we take the radius of the big circle. So basically it is 0.075. Now what is our I? Our I is pi over 64 big diameter 0.154 minus 0.114. What's the answer?
I'm getting 28.31 MPa.
28.31 MPa.
What did I do something wrong?
Good people.
Mr. Ice,
Hmm.
I made an error. It's 84.92.
Okay, no problem. We all doing this together. If there is a mistake, it's for all of us. 84.12.
92.
Okay, this is basically it, guys. Okay, we've calculated all the forces and see what is the effect of the bending. Calculate the principal stresses and the maximum stress and orientation. Okay, now we have to study at each point what are the effect of all these forces that we found and share. Let's start at point A. At point A, what is happening? We know that this direct stress here, we all know that there is an effect of a compressive force, a compressive direct stress, because that force is acting on all of them. The one that we got, that was 1.407. So we're gonna have it as minus 1.47. It is minus because it is a compressive force. Now what else do we have? Now we have to see the effect of each bending moment if it is affecting, if it is having an effect at point A. Now let's look at the first bending due to 12. When 12 is bending, is it having an effect at A, guys? Because remember, this thing is bending this direction, is bending. Definitely you can see A will feel the effect of this thing as it going up. Remember, bending means it is going like this. A will be feeling that effect. Do we agree?
Sorry, Mr. Ice.
Hmm.
Yeah, I can see that part. It's much easier to understand when you're doing the stress distribution diagram.
It is easy when we do the stress distribution diagram.
Yeah, it's much easier to analyze.
Oh, okay.
Yeah, because what I've noticed is, you see, if you take that circle, isn't?
So it is like this. This is the
So let's say
circle.
there's,
Let me erase.
yeah. So
Let me erase
especially
one.
on the bending, so you might find out that the same bending maybe on A
This is it.
positive
This is
and
how it
on
is, right?
on
That is what it is, guys. We have, this is the stress distribution. This is A. This is B. And this is C. So if you remember what I say when you do the stress distribution, if your force is coming, remember what's happening here. The force is acting straight up to it. 12 is coming to it. 12 is coming like this. Now this is how it is. The stress distribution when the force is acting on the y-axis, it is drawn on the opposite axis. What do I mean by that? If it is coming on the y-axis like this, the stress distribution, what am I saying, guy? What am I saying? Let me look at something here in the textbook before I say anything that is not. Okay, space in the bending. this force of 20. 1 minute, it's this one. Oh, 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 oh. Okay, okay, okay. This is what I meant. When a force is acting straight like this, the stress distribution is done like this. So it means it is done on the x-axis. This is how you write your stress distribution. So this simply means only at point A and C that the effect of this bending moment will be felt. But I don't know if you understand what I'm doing. So basically what is happening is, if you have, let's say you have A, B, C, and the force causing a bending is definitely acting like this. So therefore the stress distribution under this part will be going like this. This also tells you important information. Instead of looking at there how it will bend, you can already see that the point that will be feeling the effect of the bending here will be point B, due to the distribution of the stress. So under our case here, the force 12 kilonewton is coming straight to it. So we definitely know the people that will be feeling the effect will be A and B. One of them will be positive, another one will be negative, because another one will be the opposite of that stress. So that's one of the reasons why this bending here at point A will have an effect. So let's try to write and see what is happening there. That's one of the reasons here. You can write here, plus 50, 95. If you do this, so what do you get as answer? I guess we need to get
Going to be 49.48. Mr.
Hmm.
Ice. Yes, I did that. I did get that part,
Hmm.
but so basically, all we know that force is a compressive threat, is a compressive force, isn't
No,
that
it's not something to claim.
direct force?
No, I'm not
No, it is
getting your
not something
question.
to grab.
I'm not getting your question. Let me be honest.
Okay, no. So what I wanted to ask, or maybe to clarify, so that we understand, is the signs not only always on the compressive
It was catching. You say the sign is not.
tensile.
The site is not tensile.
The sign is not always depending on the nature of the force.
The
Let's
sign
say if
that
it's a compressive or
or
tensile,
tensile.
yeah,
It
or
depends
tensile.
on the nature of the force. This is what
Because you can see that, but the 50.95, is it not a compressive?
no. Okay, now I get you. Now you asking your question. The compressive is being applied when you are studying the sign of a compressive. It's a direct force coming to the point. That is the reason why you have force over area, straightforward. But under this case, what you are studying is the bending moment around.
Yeah.
It's the bending moment around the x-axis. So usually, how do you get
The sign.
the sign of this thing? You use the right hand rule.
Yeah, that's the thing. But last time, remember, you didn't, because I know that same 50 at point C, it's negative.
Yeah, it's negative because it cannot cause if you have 2 points under this case like this, one should be negative, one should be positive. You cannot have them positive or negative. They are always opposite
Yeah.
because they feel the stress at opposite position. Now, the good thing is how to get this using the right hand rule. This is where they could push it. But anyway, let me close this link because time is almost up and send a new one and we continue.
Hey, Mr. Ice,
Yes, my brother.
you see there by minus 1.47 plus 50.95. Why is it positive? Why, like the 50? Why is the 50 positive when we saying that 12 kN is compressive force?
Okay, this is what I was trying to explain even to Abubakar. The
Okay, let's
nature
wait for the others. Let's wait for the others then. Guys,
yeah, we're waiting for them. They are joining. I'm adding them and then uh,
all right.
man, I haven't even taken my shoe off since I came here. Okay, I'm just waiting for others to join. You okay, Mr. Coach? Actually, you are asking the same question as Abubakar. What I was trying to say is, do you see when we have a compressive force? The compressing force is creating a direct stress straight to the object. There we can see the sign if it is positive, if it is negative because it is compressive. But now again, that does not mean that the moment should be negative. Remember, the moment depends on two things. You have the force and the perpendicular distance. We have the force and the perpendicular distance. Okay, guys, I don't think people will be joining. Let's start. If they join, pretty sure this is recording. Okay, this is the thing that we were saying earlier. This force is creating a compressive force. We agree it's negative. That does not mean the moment should be negative. Now, let's see what is happening. This is force 12 times perpendicular distance. It is creating a moment about the x-axis. Creating a moment about it means the object will rotate like this around the x-axis. So now, to determine the sign of our moment, you study actually the curve. You represent the curve the way I'm doing like this, and you use your right hand rule, where uh, where where your four fingers follows the arrows and your thumb give you the direction or the sign of your moment. If it is going same direction as x-axis that you've chosen, it is positive. If it is going opposite direction, it is negative. The thing here, the good question is how to use the chain rule. So how are they getting that moment to be positive? You push your right finger following the curve, because this is the direction that it is bending like this, following here, following here, following here, following here. Okay, you put your palms and finger in the direction of the arrow, you hold it. Oof, the thing is you can't see what I'm doing. Let me this thing is, how can I explain this? How can I explain this so that you can see what I am saying? Sorry. How do we do
Next
this?
rest.
Huh?
I, I will send. I just got one or two videos, so I'll just send link.
Send please the link.
Yeah. Then we'll just check it.
Ooh.
Maybe we can carry on
Now what
instead of wasting time.
we need to know the sign. But anyway, you guys are reaching tomorrow. By tomorrow I need to get this channel right so that we know what we are doing.
Yeah, I just sent that.
Or you just share the link, okay. Okay, no problem.
Yeah.
But Mr. Colso, actually the idea, this sign is depending where the bending moment is occurring. And to study that sign, we have to use the channel. It is not depending on where, if the force applied is a compressive, it means that bending should also be compressive. No, it's not like that. Did I at least answer you that one theoretically?
Yeah, because when I was doing I was confused. So I tried minus, I could not find the answer, and put plus there, I found the answer. You know how it is. So, but
No, but
yeah,
you must get the channel. But anyway,
yeah, now I know. Because last time you said something about the end right end rule, but you
right and
didn't
roll,
show
yeah.
us how to do it.
I'm
So
saying it
yeah,
right now.
reason I struggling a bit.
Oh yeah, yeah. So these are the stresses that you get under A here. What do you get? 59, 49, comma 49, comma
Yeah, we should get there 49.48.
48. On the textbook I see here you get 5, 6.
Textbook.
Hmm.
Oh yeah. Textbook, man. Okay, let me.
No, it's due to the rounding. We've been rounding
Yeah,
answers.
the rounding and all those things.
Yeah,
Yeah.
you don't have to worry
So
about
just
it.
be getting close answers.
Now we are studying
But I guess
the effect of
that man will let us
hmm,
know if we should run, how should we run the stuff.
the at point A. This is what we have as direct stress. What else do we study when we are at point A? We also study the rho xy. What is the rho xy? It is the shear stress. It is the shear stress. Now, how do we study the shear stress? Remember this distribution that we did here. I said if the force is acting straight here, what is that force creating a shear? Wait. Oh, what am I saying? We are still at point A. At point A, we say that for the stresses, this and this they are adding because this is having an effect at A. Now let's look at, is the shear stress having an effect at A as well? This shear stress, yes it is, because the force creating a shear stress, it is 10,000. It is basically acting here. Due to that, A will feel the effect of the shear stress. I don't know if you see what I'm doing, but this is basically what I've explained here. The force is acting here, only A and B can feel and C can feel the effect of the shear, because B is on the neutral axis. The neutral axis, it is the axis at which the force is operating. So now definitely, because we know that B will be the neutral axis, so for the shear stress here, what are we gonna be having here? For the shear stress here at A, you're going to have this shear stress that you found here. It is 1,69 1,062 megapascal. That's what you have. What else do we have? Cindy?
Hello, Mr. Ice.
Yeah, I'm good. We are trying to do this question here. It's chapari, but it's fine. What else do we do here, guys? What else do we do? We know that this shear stress will have an effect at A. What else? We also know that the torque that is being created is also having an effect here. This rotation here, where point A and B, C are located. That is the reason under this case, the one that we call rho xy, this one, rho xy, y here will be this force. Now what is the sign? This one is 42. Again, we are having a problem with the signs here. 42 comma what? 4 6. Are they adding or are they subtracting? This is where we still use the right hand rule. So the right hand rule is very important here. Let me check something here. So Mr. Bubaka, if you do we have, I just want to check 1,62
Yes, Mr. Ice.
under this whole xy here. What did you get?
Me,
Hmm.
so me, the way I did it is
Did you
on
get
stress,
two point?
at point A, I didn't consider the I just considered the torsional stress,
No, that's wrong. That's wrong.
isn't it?
These two, they are adding.
Because I just added them on point C.
No, it's also added on point A. Remember, A and C, they are on the same line. Whatever A feels, C feels it, but more likely with an opposite sign of A.
Yeah.
So whatever you do on C, you do on A. Under this case here, this one here, the 2 here needs to be added. If you add, what do you get?
If I add
You need to get 43 comma,
yeah, 43 point.
it is 43 comma maybe 6 something. What is it again, the answer?
No, sorry. So 1.02 plus 42.46.
43,522.
Comma 5.
22.
This is what they get as NPA for A. So now for A, this is everything that you get. What do you do here? You now use those formula that, remember, that I've told you that we've been using here to get the stress 1 and 2, and then to get the maximum stress. Remember that formula, stress 1 and 2. So for each element you have to do this thing. What was the formula again? What's the formula again? I think it is half rho x minus rho y. I'm just trying to remember, plus minus half. We've seen this formula. I think it is rho x minus rho y. Is it everything square, or it is only plus 4 times rho xy square? So now what's happening here? Remember, your rho y here is always taken as 0. So the stress that you found here as the main one, this is the one that you consider as rho x. So here you will be having half 49.48 plus minus half root of rho x 49.48 minus rho y doesn't exist, so it's 49.58 square plus 4 rho xy, it is that 43 43,522, you do it square. If you can calculate this, you're gonna have one row to be positive, another one to be negative.
So you see on that one, I'm getting 74.78. They can confirm there.
This one, the first one,
Yeah,
70,
with a plus.
yeah, 70,
74.478.
74.4.
Can someone else confirm, please?
It is MPA. The second one, what do you get? What you get is what we are writing, Mr. Bubaka. We trust you.
Always about check. I can make a mistake, man. Minus 25.3.
Okay,
You see,
minus
the, yeah, the answers are a bit far from the textbook one, but yeah.
Nah, are we done? We are not done.
Okay.
The direct stresses were this one that we were finding, which is across this. Now we want to find the maximum stress. To get the maximum stress, what do? The maximum stress, it is rho max. It is rho 1 minus rho 2. Rho 1 is 74,4 minus of the formula, and this minus makes it plus. Now everything is divide by 2. What do you get as answer?
49.89.
49.89. This is the maximum stress. 49.89. Oh, this thing. MPA. So this is the maximum stress at point A. Now let's see, what do they get as answer here at point A? Do they got something as 49?
Yeah, it's 49.56.
So this should be it. Now let's look at point C. You have to do the same thing, guys. At point C, remember C and A, they feel the same thing. So basically at point C here, this answer here will remain the same. This one. Now what is changing on the shear stress? No, it won't remain the same. It won't, because whatever A feels, C feels it with negative, with opposite sign. So basically you'll be having -1, so -1,47, negative what is that number again? -50,95. Sorry. What's the answer?
So it's going to be negative 52.419.
It is 52.
419
minus 52.419 megapascal. Now let's see what is happening.
Just 0.42.
What is happening on the shear stress?
Mr. Ice, this part.
Sorry?
Hey, Mr. Ice.
What, my brother?
I'm saying the one that we are calculating now, it's
Point
occurring
C.
at C,
At
at
C.
point C.
Remember, whatever A feels, C feels it, but with opposite signs. They are both along the same line. Whatever A experienced, C will experience that, but with an opposite sign of it. That's the reason I'm doing A and C. So the effect what A will experience, C will experience them with opposite sign. That's the reason under this share here, this one is negative. Now under the whole xy, what's gonna happen? Under the whole xy, we have this shear stress here. This shear stress will be negative, but the shear stress due to the torque here will be the way it is because it's acting straight to it as it is rotating. So here you'll be having minus at point C. At point C, the shear stress here will be minus 1 comma 62 plus 42 comma 46. So what do you get when you do this?
Country in Africa do you think has women that have hash? South Africa. So South Africa has hash and they don't have hash. Let's just come to South Africa. Because Nigeria right now is like
So yeah, what do we get?
It's kg.
41.4.
1.4 MPa. Now guys, can we try to put this under this formula and see what it's gonna give to us? Look what's gonna happen. This is the direct stress here. Half, you replace this by 52. Everywhere there's replaced by 52. The rho xy you replace by 41,4. Just the way it is. And you give me what do you get as rho 1 and what do you get as rho 2. What do you get as rho 1
The
guys?
first one is 22.
Is 22.
It's 22.79.
0.79. Guys, tomorrow I'll
0.79.
confirm these sign things without any doubt. You'll be able to solve this problem without any problem. This is just a procedure. The second one I know is gonna be negative, but I don't know what negative it is.
Negative 7.5.
Negative 7.5 comma.
0.21.
Now what do you
21.
get when you do the whole max here? Remember it is this force 22,79. It becomes plus because there's a minus of the formula and this minus be plus 75,21 divided by 2. What do you get? Please get that answer.
It's 49.
You get 49 comma. You need to get the same answer.
Only 49 straight MPa.
You get 49 straight. Okay, guys. Basically, if you look at the textbook, they wrote this solution to be plus minus. Basically, what's happening? The answer that you get as maximum here at A will be the same at B, but one will have an opposite sign. This one has to be 49 as that one. It means there is a rounding thing that we are doing wrong. But anyway, that's how you do it. Now, what is the last point left of studying? It is point B. Now, you have to look at point B here. Look at point B. Let's see the effect of each force at point B. At point B, we know it will experience also this direct force. So this one is already there. What else is it gonna experience? We know that at point B, there will not be any effect of this shear stress here, because this shear stress is acting where there is B, so it will not exist. What else do we know? Let's look at which bending moment will have an effect at B. We already know that the bending moment of 12 here, this bending moment of 12, let me lift it here, of the first 12 kilonewton here, will not have an effect of B, because this 12 is having an effect on A and C. Now, let's look at what other bending moment. This bending moment of 10, look what is happening. This bending moment of 10, you can see it is acting here. Therefore, look what we did with the stress distribution. The force is acting straight up like this, so the stresses are going like this. I don't know if you see what's happening. Look here, the force of C, why is it acting? Because this one was coming straight to B, this one is going away to B. Definitely the stresses must look some type away like this. Due to that, only the bending moment of this will have an effect at B. So definitely, if we have to do the same thing that we did at B here, what you will be having at B for all the stress, I know that compressive stress that we got, that minus 1,47 is here. You will be adding or subtracting with this bending moment, this one here of 84,94. Now, the good thing is the effect of the shear stress due to the force, this formula of V equal, it will not apply at B, because that's where B is. The force, that force is actually at B. B is on the neutral axis, so these will not have any effect at B. So definitely we only gonna use the shear stress due to the torque. That is 42,46. So guys, you do this, you get this, you get this, you do the same thing again. What do I mean by the same thing? You have to get rho 1 and rho 2. Remember what we did. You know the formula. It is half the answer that you get here. Now, what I owe you is sign using the bending moment. That is what I owe you. And I believe that that's the only thing that is missing. To solve B, you know what to do, guys. You have already your rho xy, you know the formula. Whatever answer that you get here, let me say it is 83, what? You get that 83, something here. It's gonna be minus that thing, that is 0, plus minus half. You have again that 83, what that you get here, square, plus 4 times this one, 42,45. This one square multiplied by 4. You're gonna get rho 1 and rho 2, and you know what to do after to get rho max. Now what I owe you, because remember even for the torque we need the sign, what I owe you is how to get the sign of this how to get the sign of the bending moment. But to get the force and calculation, it is straightforward, guys. Any other question?
You.
Any other question?
I know. Thank you. This side.
Okay, guys. I will post all the videos that I have not posted. I know there are a lot. It's gonna confuse me, but I'll take time to post them. Then you will get it. So thank you, guys. I will see you.